The largest planet in our solar system, Jupiter, has gravity so strong that it can even affect Earth's climate as well as protect us from comets. This swirling gas giant has been stoically watching over the solar system for billions of years and is so vast it's visible from our planet with the naked eye. But there are still many things we have left to learn. This is Unveiled, and today we're answering the extraordinary question, did scientists finally solve Jupiter's X-ray mystery?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
For 40 years, strange behavior in Jupiter's atmosphere has been confounding scientists. It's been known for decades that Jupiter has vast auroras, just like Earth does. But unlike Earth, Jupiter's auroras produce large bursts of X-rays at regular intervals. On Earth, the northern and southern lights, though the latter is visible in fewer places, are ultimately caused by the sun. The sun's upper atmosphere releases a stream of charged particles known as the solar wind, which interacts with the Earth's magnetosphere, causing the phenomenal light shows we know as the aurora borealis and, in the southern hemisphere, aurora australis. During solar storm events such as coronal mass ejections, when magnetized plasma erupts from the sun out into space, the lights can be particularly bright and spectacular. And Earth and Jupiter aren't the only planets that have auroras. Saturn, Uranus, and Neptune do as well. But Jupiter remains the only aurora that produces X-rays like this. And in 2021, it looks like scientists have finally unraveled this mystery. Evidence gathered over decades of investigation from various probes and missions, most importantly Juno, has shown that bizarre disturbances within Jupiter's magnetosphere are to blame. Ions inside Jupiter's magnetosphere, which is 20 times stronger and 20,000 times larger than Earth's, are superheated by solar wind. After traveling through the magnetic field lines, they're eventually released in enormous bursts of energy, blasting out X-rays. But that's not actually the end of the mystery. What triggers this release are vibrations in Jupiter's magnetic field line, and we're not sure what causes them. The mechanisms responsible might still be interactions between ions, electrons, and plasma, but we simply don't have the data or the knowledge just yet to truly explain why this happens. It could also have something to do with the regular release of heavier elements by Jupiter's volcanic moon, Io. For all these unknown factors, Jupiter's auroras are still very similar to Earth's, just far larger and creating exponentially more energy. In fact, just one of Jupiter's auroras produces enough raw energy to power the entirety of Earth for a brief time. Our observations have also shown that the X-rays happen like clockwork every 27 minutes, which makes them very reliable. Does this mean that potentially Jupiter's X-rays could be an infinite power source for us here? Maybe, if we could come up with a way to harness them. If we did, we'd have a nigh infinite power source on our hands. Since as long as the sun is ejecting plasma, which it will do for billions of years to come, Jupiter will keep releasing X-rays. We wouldn't be exploiting any finite resources to generate power in this way, and we'd get a significant amount of energy at predictable intervals. Already, though we can't harness our own auroras for power, they do affect Earth's electronics in major ways. Solar storms and flares can interfere with communications and potentially even cause blackouts and disable satellites. And the northern lights have been documented to cause damage to infrastructure, including power cuts, and can affect planes. Planes may have to change their routes to avoid a particularly powerful aurora here on Earth. But gathering the energy produced on purpose is a completely different thing, akin to trying to generate electricity through lightning. It is technically possible to use ground lightning as an electrical source, but it's so difficult and expensive that nobody tries. Lightning is extremely unpredictable, far more so than auroras, and much rarer. It also produces an enormous amount of electricity very quickly. The most powerful cable in the world has a voltage of over 500 kilovolts, or 50,000 volts, whereas an average bolt of lightning carries 300 million volts in a matter of seconds. So we don't currently have the technology to harness every volt generated by a bolt of lightning. We'd also need to transfer the energy into a battery, and while we do have batteries that can handle this, they're extremely expensive to produce. And once again, lightning is unpredictable, and there's no telling we'd actually be able to use these costly batteries and cables with any regularity. In contrast, we're already very adept at using solar radiation for power in a very different way, because that's how solar panels work. The light a solar panel collects and turns into usable electricity is electromagnetic radiation, and some solar power stations generate immensely more power than many traditional power stations. Jupiter is much farther away from the Sun than Earth, and so it would be trickier to get as much energy as we'd need if we were to ever travel to Jupiter and beyond ourselves. That's why finding a way to use the auroras could be extremely useful. Once we were near Jupiter, they'd be much closer and more reliable than just sunlight and could easily power entire Jovian moon colonies. Of course, to do this, we not only need to learn more about Jupiter's auroras, but also about Jupiter itself, which still has plenty of mysteries waiting for us to solve, including the mystery of its own lightning storms. Yes, Jupiter has large concentrations of lightning. Though unlike on Earth, Jupiter's lightning occurs primarily at its poles rather than its equator. Jupiter's lightning took so long to definitively discover because it appears in a totally different range to Earthbound lightning. It is also bizarre because here, lightning is related to the Earth's surface. Half of all lightning on Earth comes from the ground up, and the ground's electrical charge is what attracts lightning from the clouds to strike, and vice versa. But Jupiter doesn't have a surface because it's made almost entirely of gas, so it's not clear how its lightning works. The jury is also still out on whether Jupiter has a rocky core at its center. It certainly might, but we don't know for sure whether that, or something far weirder, is happening at Jupiter's heart. And Jupiter's notorious storms and strange atmosphere have even more unusual features. Those same lightning storms also produce something called mushballs, which are slushy hailstones full of ammonia that might carry heavy elements and molecules, like water, deep into the dense clouds. There are also plenty more questions about Jupiter's famous Great Red Spot, an intense anticyclone. Anticyclones on Earth are responsible for creating tornadoes and sometimes blizzards, but Jupiter has the biggest storm anywhere in the solar system. Though Neptune, which is also prone to anticyclones, has its Great Dark Spot as well. We don't even really know how old the spot is, but it's been visible there for as long as humans have been able to see the Jovian surface, which is centuries at the very least. Scientists also aren't in agreement about whether the storm is beginning to dissipate or whether it's just changing its appearance, looking smaller to us here on Earth, but still just as powerful. Not only is Jupiter itself a mystery, but so are its moons. Io, one of the largest, is the most volcanically active body anywhere in the solar system, and again, might be contributing to the bizarre X-ray auroras. It's got hundreds of active volcanoes and is so covered in sulfur that it appears bright yellow. And of course, there's the most intriguing moon of all, Europa. Europa is an icy moon with a subsurface ocean that many have speculated could play host to alien life. Considering Jupiter itself seems to have all the elements necessary for life aside from water, which is yet another mystery unto itself, there is a strong possibility that something remarkable is lurking beneath Europa's surface. It's clear that we still have plenty to learn about this stunning planet, and slowly but surely, we're chipping away at Jupiter's secrets. And that's why scientists have partially solved Jupiter's X-ray mystery.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.